We had done packet page 14 and 16, so we're going to knock out 15. And this is a two-proportion Z test, and it's two-sided because it's not equal, obviously. So there's a survey of 25,000 randomly chosen Americans to see who had finished high school at a higher rate, the men or the women. So we'll define the parameters. P sub F, that's the population proportion of female high school graduates, and P sub M is the same for male high school graduates. And is there a difference? So HO, P of the men equals P of the women, no difference. And the alternative is that they're not equal, all right? And it's a 5% level. So the samples were told to have been picked randomly. There's men group and women group, so those are independent. Populations are easily at least 10 times the sample sizes. And then N times P had all of those products are quite a bit larger than 10. So your sampling distribution is approximately normal. So I ran the test and I put the women in first. You can put the men in first. It doesn't really matter for a non-directional test like this. So I got a very big Z-score, 7 standard deviations above the mean. And the p-value, I don't even remember it. It had scientific notation. It was really small, so I went with 0. Here's our blended p hat without the subscript, and I wrote down the alpha so that it's real close to the p level. And P is quite a lot smaller than alpha, so this is very significant. And we reject HO, so we have strong evidence to believe there is a difference in the high school graduation rates between female and male students, all right? What I did was I did a confidence interval, and I put females in first. And since a confidence interval is two-sided and a two-proportion Z-test is two-sided, they match up perfectly. So you don't have to do any finagling. So here's what I got for my 95% confidence interval. 0 was not there. No surprise, we rejected that they were equal. And I got both positives. So it seems that females have a higher graduation rate, because if I subtract one quantity from another and it turns out to be positive, that first quantity that I remove something from has to be bigger than the second quantity. So females seem to have a higher graduation rate. And you can just use this as evidence in place of all of this stuff. And that would be great. All you have to say here is since 0 is not in the interval, the results are significant and we reject HO and blah, blah, blah. You can just continue on with that. Okay, so what I want to do now is show you that you should be able to do a confidence interval in place of a test of significance for something that is one-sided, but you have to kind of watch out. There'll be a little bit of a difference. So let's start out. I'm just going to make up this test of significance. I'm going to say HO is that the true proportion equals point, let's say 30, and HA is that the true proportion is greater than 0.30. All right, this is a one-sided test. And whoops, let me fix that. And with greater than, I believe that's going to put us on the right side of our curve and our sampling distribution, all right? And let's pick an alpha, something kind of obvious or something kind of normal to pick. All right, so that would be 0.05. And since we're standardizing everything, let's just center that at 0. And let's put alpha right here. This is alpha equals 0.05. And let's just say anything that starts in there going to the right is going to be rejected. And let's just say we run this test and we get a p-value, and that'll be equal to 0.03. All right, so that would put us sort of like right in here, and it would be entirely in the rejection region. So in a case like that, we would reject HO. So P is less than alpha. So results are significant, and we reject HO. Okay. So let's just say that we're not really all that caught up on switching from a test of significance like this to a confidence interval to do inference, and you just saw my example and you said, all right, then like in the previous example, C95 would be an equivalent. Okay, well, let's just check that out. All right, so here's a curve. I'm going to try to line that up as well as I can to the other one, but this is hand-drawn. Okay, if this is C95, that would put your central value of 0.95, and then that would put you kind of like here. This would be 0.025, which is half of what's left over, and this is 0.025, right? So anything that ends up here sort of gets rejected. Well, what happens is if we extend this down, and I really did kind of want to make that red, so let me just kind of switch that to red, sorry. So let's just bring this down. And that does not go into the rejection region, all right? It's not drawn super well, but it's going to look pretty much not all that unusual, right? So we can't use 0.95 as the confidence level because you're not getting a match between these two tails. So let's just kind of back out of all of this and let's just kind of correct. And let's just say, okay, well, let's just match up with what we have here and put 0.05, whoops, I keep forgetting to change colors here. Let's change that color. And let's just put 0.05 here. And let's just put 0.05 here because it's got to match in a symmetric way. All right, well, that's going to change that to 0.9 because the whole thing has to add up to 1, right? So you actually have, this in place, and now it matches up here, but we can't use that. We're just going to have to go ahead and use C90. So in a one-sided situation like that, you can't just go ahead and subtract 0.05 from 1 and then create a confidence interval at that level. You're going to actually have to examine the geometry a little bit so that whatever your rejection region is here gets matched here, and whatever is here gets matched over here, and so that's going to drop your confidence level to from 95 to 90%. Does that make sense? Hopefully it does. Most people don't use confidence intervals. I mean, in class, in the professional world, maybe it happens all the time, but in our class, if it says to do a test of significance, just do a z-test or later on a t-test or a chi-square or whatever, and forego the confidence interval. But if for some reason you do it and you're able to match up your confidence level to the alpha, then that's fine by me and it's fine by AP. So that is it. That's what we've covered. And I'm just going to bid you a farewell, and I'll see you in class.